All right, so this video I'm going to briefly cover the number sets. I'm also going to briefly cover set notation. Okay, so first let's start with this graphic here on the right. We see that there's what, 7 types of numbers, right? 7 categories, we'll call it. Okay, so the most specific type would be the natural numbers, right? And natural numbers are the counting numbers, right? So these are the numbers we use for counting. And depending on what book you read, it includes zero. Um, I'm going to go ahead and include zero, zero, 1, 2, 3, 4, 5, 6, on and on and on and on and on. Those are your natural numbers. Then you have what's called the integers. So integers include the natural numbers, right? But they also include, so they include 1, 2, 3, etc., right? But they also include their negative counterparts, right? And obviously, of course, also zero. Um, all of these numbers, so any whole number, any whole number is an integer, whether it's positive or negative, right? Then you have got what's called the rational numbers, represented by the letter Q, right? And I forgot to mention, so these super, fancy looking letters, they represent the actual number sets. So when you see in mathematics, a fancy looking N like this, know that we're talking about the set of natural numbers, likewise for Z and Q, with respect to integers and rational numbers. Anyway, rational numbers are any numbers that can be written as fractions, right? So that obviously means any fraction. So 2 over 27, that is a rational number. It's a rational number because it's expressible as a ratio. Now, you're probably wondering, well, why does that include the whole numbers right here, right? And the reason that it includes the whole numbers is you can take any integer or natural number, let's say -5, and express it as a ratio, numerator to denominator, -5 to 1, right? So that means -5 is also a rational number, even though it is a whole number. You can also express, so let's say, -6, let's do +6. So +6, well, I could say 36 over 6 is also equal to 6, right? I'm expressing the number 6 rationally. So it is a rational number, so long as I can do that. So rational numbers, you also have numbers that are not rational. Okay, and that means you cannot express them rationally, right? So these numbers are not expressible as fractions, at least not in the sense of one integer relative to another, right? These numbers would be your ugly square roots. So let's say square root of 7, square root of 2, the cube root of 6, right? I mean, just anything that's going to give you a decimal that goes on and on and on and on and on, and it's not repeating, right? Because 0.6 repeating, well, that's 2/3. 0.3 repeating is 1/3. Those are rational, but these have no repetition in them. They can't be expressed as a ratio at all, and that's, I'm leaving out some important irrational numbers, particularly pi. Pi is an irrational number. It can't be expressed as a fraction. 3.15926, blah, 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 blah. It just goes on and on and on forever. Another one would be the natural base Euler's number, E. I always forget what that decimal estimate is. It's 2 point something. But anyway, there's also Planck's constant. There's a lot in science, in natural reality. Natural numbers occur a whole bunch, or not natural numbers, irrational numbers. Obviously, natural numbers too, but that's a whole nother story. And the largest encapsulation of what you've studied so far in grade school is the real numbers. And the real numbers include rational and irrational numbers, which means they include the whole numbers too. Positive or negative, including zero, including pi, including Planck's constant, including -5, including 2 over 27, right? These are all the numbers that you have ever studied in your entire life. These are the real numbers. And they're real numbers because they have real roots, okay? we'll get into that. But these include the irrational numbers. These include any number that could be a fraction or a whole number, etc. Anything you've ever studied thus far. Okay, coming out of that, we have this weird classification off to the side by itself, kind of like the irrational numbers, except even weirder. Imaginary numbers. Imaginary numbers, technically there's only one, and that is the imaginary unit I. And we'll learn more about that in another video. But the square root of -1 is I. That is the imaginary number. And even further, you have the complex numbers that encapsulates everything, right? So all the real numbers, all the imaginary numbers, rational, irrational, integers, and natural numbers, they're all considered complex numbers. That's because they're expressible like this: a plus b times I, where a and b are real numbers and I is the imaginary unit, square root of -1I. And again, I'll go into a lot more detail on those in another video. But real quick, let's go through this set notation and just get an idea. So now that we've briefly gone over what the number sets are, let's look at some of these. So this is what's called set notation. And if we were to verbalize these, what we would say is that we have some number x such that x is a real number, or not a real number, x is a natural number, and x is less than or equal to 0. So if I was going to verbalize that, x such that x is a natural number and x is less than or equal to 0. Right, so that's how I would verbalize that statement. Let's look at another one just to make sure that we've got it. So here we have some number f such that f is an integer, right? An integer here. And f is greater than or equal to -3. Right? Then you've also got another example here. Y such that y is a real number and y is greater than -infinity, but less than infinity. So that means y could literally be anything in here, right? And last little example, some number t such that t is a real number and t is greater than or equal to 0. Okay, so real quick, let's talk what some of these things mean. So this bar right here just means such that. This right here is the Greek letter epsilon, right? And it just means that it's a part of, it's an element of, right? So x is an element of the natural numbers, right? Or x is in the natural number set. Okay, and then obviously we know what these mean. These just tell us the nature, right, of the actual variable, the actual number that we're talking about. Okay, so that was a crash course on set notation and a crash course on the number sets. A lot of this probably wasn't new to you, but all the same, just in case, there you have it. So if you have any questions over set notation or over, the number sets, shoot me an email. You know where to find me. Goodbye.